Welcome back. We will continue with our problem solving on fluid viscosity. We have a problem here which states a Newtonian fluid is filled in the clearance between a shaft and a concentric sleeve. We have already seen this in one of the problems. So you have got a shaft and then you have got this shaft between two sleeves. So this shaft is going to be rotating and this sleeve is going to be stationary. Okay. And they have said that the sleeve attains a speed of 50 centimeter per second when a force 40 Newton is applied to the sleeve parallel to the shaft. So when you have a force of 40 Newtons, the sleeve attains a speed of 50 meter per second, or let's say zero 0.5 meter per second. Okay. And they want us to find what would be the speed if a force of 200 Newton is applied. Okay. So since there are two forces, so let's denote this with F1 and F2 and the corresponding velocity with U1 and U2. Okay. I'm supposed to find out the value of U2. So now what we know is tau is mu times U by Y. Okay, so it is a Newtonian fluid. So for both the conditions 1 and 2, mu is going to be constant and y is also going to be constant. Okay, what we do know is tau is force by area. So we can say force by area is mu times u by y, or F is mu times a into u divided by y. So of these four parameters over here, this guy mu is going to be constant, area is going to be constant, and y is going to be constant. And the variable is u. So this is the parameter that is going to change. So I can say f is directly proportional to u. Or I can say f by u is a constant. So if f by u is a constant, I can write f1 by u1 equal to f2 by u2. And I am supposed to find out the value of u2. So it is f2 divided by f1 into u1. So that is 200 divided by 40 multiplied by 0.5. So this is going to be 5 times 0.5, which is 2.5 meter per second. So it's quite a simple problem over here. Let's move on to the next problem. So this is pretty similar to what we have done earlier. So I would request you to do this on your own. Let's try and do this. Two large plane surfaces are 2.4 centimeter apart. The space between the surfaces is filled with glycerin. So we have got two plane surfaces. Both of them are stationary. So I have got two plane surfaces. Both of them are stationary. Okay, and the space between these two is filled with glycerin. When force is required to drag a very thin plate of surface area 0.5 meters squared between the two large plane surfaces, if the thin plate is in the middle of the two plane surfaces. So you have got a plate, and that plate is placed exactly in the middle of the two plane surfaces. So they initially said that these two guys are 2.4 centimeter apart or 0.24 meters apart. So this plate over here, this is 0.12 meter apart, or and this side it's going to be 0.12 meter apart. Okay. So they have said it's a very thin plate. So this thickness of the plate can be considered negligible. So it's simply 0.12 from the top plate to the top surface of the plate. And from the bottom surface of the plate to the bottom plate, it's going to be 0.12 meters. And the area of the plate is given as 0.5 meters squared. And this particular plate is dragged with a velocity of 0.6 meter per second. See, what you should understand is now they want us to calculate the force required. So the parameter that we are supposed to find out is F. And additionally, they have asking us to find out the dynamic. They have given the dynamic viscosity as 8.1 into 10 to the power minus 1, which is 0.81 Newton second per meter squared. So what we have drawn is for the first condition. The second condition, the distance is 0.8 meter from one of the plane, and from the other plane, it's going to be 1.6 centimeters. Okay, so let's concentrate on the first subdivision over here. The plate is exactly in the middle of the two plate surfaces. They want us to find out the force. What you should concentrate here is this plate has got two surfaces. So this top surface, there is a top surface of this plate, and this will experience a force F1. And this plate has also got a bottom surface, and the bottom surface, which I am denoting with this blue color over here, this will experience a force F2. So now, when they ask you to find out this force F, that is going to be the summation of F1 and F2. So we need to find out the value of F1 and F2, and then we have to add both of them. Okay, so we are dealing with viscosity. So what we know is tau is mu times du by dy, or let's say mu times u by y. We have done that so many times, so let me write it straight away, mu times u by y. And this tau is also f by a. So let's say F1. So here Y1 is 0.12 meters and Y2 is 0.12 meters. There is no change in the velocity. So U1 and U2 both are U. So we can write F1 is mu times A into U divided by Y. Okay, are these values available to us? Yes, the value of mu is 0.81. The value of area is given as 0.5. The velocity is 0.6 and the distance is 0.12. And if you use the calculator, for solving this problem, it's going to be 0.81 times 0.5 into 0.6. This whole term is divided by 0.12 and we get 2.025 newtons. So let me say it is 2.03 newtons over here. Okay, now we are done with one term, which is F1. We are also supposed to find out the value of F2 as well. So let me use this side of this space which is remaining over here. So F2 is mu times, so this is y1, mu times u, sorry about that. Mu times a u divided by y2. And so that's going to be 0.81. There is no change in the area, 0.5. There is no change in the velocity, 0.6. And y2 also happens to be 0.12, and there is no change. So F2 is also going to be equal to 2.03 newtons. Okay. This is 2.4 centimeter apart, right? So it's going to be 0.024 meters. So this guy is supposed to be 0.024 meters, which is, so this distance, what we have here, what happened to this? Let me use, so let's say this guy is 0.012 meters. This guy is 0.012 meters. So this guy is also 0.012, 0.012. So this is 0.012 here. So that makes it 20.3 newtons. The value is 20.3 newtons. So this guy is supposed to be 0.012, and this guy is 20.3 Newton as well. So your total force is going to be F1 plus F2. Somehow I have missed this. So this is 20.3 plus 20.3. So the final answer is 40.6 Newton. So that is the force that is required to drag this thin plate when it is placed exactly between the two plane surfaces. Okay. And the next option is when one side of the plate is at 0.8 centimeter, the other one it is at 1.6 centimeter. So let's solve for that. So for the subdivision 2, so I have a fixed plate over here, then another fixed plate over here. This is my plate right now. And the distance of the plate here, this is y equal to 0.8 centimeter. So that is into 10 to the power minus 2. So it is 0.008 meters. So let's call that as y1. And y2 is supposed to be 1.6 centimeter because the total distance between the two plates are 2.4. So this should be 0.016 meter. Okay, so this is y2. And this is dragged with a velocity of 0.6 meter per second. The area of the plate is 0.5 meters squared. And the viscosity is 0.81, I believe. Yes, it is 0.81 Newton second per meter squared. In a similar way, here also, the plate will experience a force F1 on the top surface, and it will be experiencing the force F2 on the bottom surface. So F1, just like we did in the previous case, that is going to be mu times A times U divided by Y1. So that is 0.81 times 0.5 into 0.6. And now y1 is 0.008. So that should give me a value in Newton. And F2 is again mu times A U multiplied by y2. So that is 0.81 multiplied by 0.5 and 0.6 whole divided by 0.016. And so the final force is the summation of F1 and F2. So let's see what we get for that. So we have got 0.81 into 0.5 into 0.6 whole divided by 0.008. So that is 30.38. So if we divide the same with 0.016, we have got 15.19. So if we add these two, we would get 45.99. So this is 30.38 plus 15.19. And so the final answer is 45.99 newtons. Okay. Let's move on to the next problem. A vertical gap 2.2 centimeter wide of infinite extent contains a fluid of viscosity 2 Newton second per meter squared and specific gravity 0.9. A metallic plate 1.2 by 1.2 by 0.2 is to be lifted up with a constant velocity of 0.15 meters per second through the gap. If the plate is in the middle of the gap, find the force required. So now in the previous case, we saw horizontal plate. Now they are talking about vertical plates. So we have one vertical plate over here. And there is another vertical plate over here. Between these two plates, we have got another plate. And this plate is lifted up with a velocity of 0.15 meter per second. And they have given the dimensions of this plate, which is 1.2 meters into 1.2 meters into 0.2 centimeter. So that makes it 0.24 meters squared multiplied by 0.002 meter. So that would be 0.0048 meter cube. I'm correct, I believe. So this gives you the volume of the plate, which is represented by V. The gap between the plate is given as 2.2 centimeters. And this plate is exactly in the center, which means this distance is going to be 1.1 centimeter. And this distance is going to be another 1.1 centimeter. So if we call this as Y1 and Y2, so Y1 is 1.1 centimeter, which is 0.011 meter, which is same as Y2. And they have said the weight of the plate which acts in the downward direction, which I represent by W. So that is 40 newtons. Okay. And what else is given is the viscosity of the fluid that is given as 2 Newton second per meter squared. And the specific gravity of the fluid is given as 0.9. So by experience, we know that S is going to be density of the fluid divided by density of water. So which implies density of the fluid is going to be 0.9 multiplied by 1000. So that should give you 900 kilogram per meter cube. Okay. So what else is given to us? So these are the details that are given to us. And what do they want us to find out? They want us to find out the force required to move this plate. Okay. Now I want you to understand one thing. One is this plate has got two surfaces. On this surface, it is going to experience F1. And on this surface, it is going to experience F2. And we have got this weight of the plate. So this weight has to be taken into account. So this weight will be balanced by or counteracted by the buoyant force, which we'll be studying a little bit later when we talk about fluid statics. And there we will see that as hydrostatic law. So the buoyant force opposes the weight of the object that tries to settle down. Okay, so that force also needs to be taken into account. So if we take that into account, so we need to balance the weight of the plate with a reference to the upward thrust that it has. Okay, so that will be the net force that will be acting on the plate to lift it up. Okay, so we need to take that also into account. So we will say we have got this F1 plus F2 plus the upward thrust minus the weight of the plates. Okay, so we need to take care of all these things. So F1 and F2, we already know how to do that. So F1 is going to be equal to mu times A times U divided by Y1. So the area of the plate that is going to be 1.2 by 1.2. 0.2 centimeter is nothing but the thickness of this plate. So the thickness of the plate is going to be 0.2 centimeters. So that needs to be deduced from uh, the value of Y1, isn't it? So if this is going to be the center line, so the thickness of the plate, so if I have this as my axis over here, if this is my axis over here, so on this side, it's going to be 0.1, and this side, it's going to be 0.1. So 1.1 minus 0.1, that is going to be 1 centimeter. So this guy is going to be 1 centimeter, which is 0.1 meters. So if we substitute the value over here, so mu is 2. The area is going to be 1.2 by 1.2. The velocity is given as 0.15. And y1 is going to be 0.1 meter again. Sorry, it's 1 centimeter. So it's going to be 0.01 meters. So it is 0.01. So if we use the calculator here, we would get 43.2 newtons. And the same holds good for F2 also, because the width is the same. So F1 is going to be 43.2 and F2 is going to be equal to 43.2. The next thing which we need to consider is what is the value of this upward thrust? So the value of this upward thrust is counteracted by the weight of the plate. So this is going to be the density of the fluid into volume of the fluid displaced. When I say density, it is the weight density. So it is rho times G. So that is your weight density. So I should include G as well. So this is 900 into 9.81. And in the previous slide, we have calculated the volume. What is the volume of the fluid that displaced? That is the volume which is, volume of the plate, which has displayed the volume of the fluid. So it is 0.0048. And the value of this is going to be equal to 25.43 newtons. And so now if we add all together, so F1 plus F2 plus the upward thrust minus the weight of the plate. So what was the value of F1? 43.2. So 43.2 plus 43.2 plus 25.43 minus weight of the plate is 40 newtons. And so we get 100.97 Newton. So that is the force that is required to pull the plate in the upward direction. Okay, thank you. We'll stop here and meet back in the next lecture.